Let us now look at the QuickSort algorithm. The QuickSort algorithm sorts an array by selecting a pivot value, in this case the middle value in the array, and then basically making sure that everything to the left hand side is less than the pivot value and everything to the right hand side is larger than the pivot value. By doing so, it will also split the array into two parts. The part being less than the pivot value is also said to be unsorted, and that will be recursively sorted again, as well as the part on the right hand side which is larger than is also said to be unsorted, and that will also be recursively sorted again by the QuickSort algorithm. We will now go through the code, and hopefully this will become more clear. So as you can see, the algorithm receives parameters, the first one being an array of integers called items, and then we have an int left index and an int right index. The first line declares another couple of integer values. We have I, j, temp, pivot value, and partition size. Partition size is calculated by deducting the left index from the right index and adding 1. This is just to make sure that the partition we are actually now wanting to sort does contain enough values so that it can actually be sorted. Otherwise, we've basically reached the base case of this recursive algorithm, which means we can return. So if we look at the code there, if the partition size is less than equals to 1, then the algorithm will return. The pivot value is then items at position, and this is just basically to calculate the middle. We use the left index plus the right index, and we divide that by 2 to locate the middle value of the array. So in this case, the left index was 0, the right index was 9, so 0 plus 9 divided by 2 will give you 4. The pivot value will then be 5. The value of the array, which is called items at position 4, is 5. So the pivot value will be 5. Then we have the two integers there, I and j, that is basically used as pointers, and we assign it with the left index for I, and the right index will be assigned to j. The purpose of the I and the j pointer is just basically the I pointer will move from the left hand side, making sure that everything on the left hand side is less than your pivot, and j will move from the right hand side, making sure that everything from the right hand side is larger than the pivot. Okay, the code that will do that is in this part. You can see here we have a do while, and this will basically continue until those two pointers cross. So while I is still less than equals to j, because it comes from the left and j comes from the right, then I should be less than or equals to j. If those two pointers cross, it basically means that we are done with that, and we have find the position of where the pivot value should be, which means we are done. And then we will recursively call the QuickSort, first going to the left, so the left index will stay the same, the right index will be the j pointer, and then we'll go to the right hand side where the right hand side will be the same, so the right index will be the same, and our left index will now be the I pointer. Okay, so the code that actually moves the pointer, as you can see here, while items at position j, so as you can see, it starts from the left hand side and checking that value at position I, whether that is less than your pivot value. If it is not, the while loop will basically stop, and then we'll go to the right hand side, checking whether the one at position j is larger than your pivot value. If it is not, this will stop, and then it will continue with the next part of code that will essentially do a swap. It will swap those two values around. So it basically stores in temp the value at items position 1 I, and then items at position I will be overwritten with items at position j. So the value that was stored in position j will basically be moved, or basically be stored in position I, and the one in position I will now be stored in position j. So we store it in a temp file because it's overwritten here, and then we just take the temp and store that in position j. So basically those two values will swap. After the swap, the I will increment and the j will decrement. And that is the code. So we will now look at how the code will be applied on this example.